Ahoy, Math Pirates, and welcome back to our adventure in the sea of sequences. This video is going to have focus on geometry sequences, hoping and assuming that you watched the video about arithmetic sequences so that you're familiar with the terminology and the symbols that we're using for sequences. In the previous video with the arithmetic sequences, we started off looking at 3 different sequences, and the third one was this geometric sequence. We verified it was geometric by finding the common ratio and calling that the R equal to 3. I also want us to give attention to the first term, which was g of 1 equal to 7. So common ratio is the R equals 3. And the first term is G1 equals 7. And if you can think back to the previous video, we like to know the first term of the sequence when we're using the explicit formula. But before we get to those formulas, let's remind ourselves that we can take a sequence and we can write it as a table. And we can also write it as a graph. Now, the actual sequence graph here is the dots, are these 3 green dots that I have here. Obviously, after 3 terms, was going over my scale on my iPad screen. But then I went ahead and did this yellow dotted line because I want to point out that this is a discrete exponential function. And so we want to review that back to our previous topic, which was families of functions. So we have 2 ways, and then our other 2 ways of representing a sequence are with the recursive formula. And if you remember, in a recursive formula, if we're looking for, say, the 6th term, then we need to know the 5th term, the preceding term, and then we're going to multiply by the common ratio. So with arithmetic sequences, we added it, the common difference, to the preceding term. But here, we're taking that preceding term and multiplying it by the common ratio. And then we could continue generating our sequence here by taking the preceding G6, multiplying that by 4, and getting our 7th term of our geometric sequence. Remember that the other formula was called the explicit formula. And with the explicit formula, we want the first term, and that's why I made a note earlier in the video about the first term being 7. And then you can see that we're again using our common ratio, which was 3. And we're raising that to a power of n minus 1. So once again, we have some key variables here, the n, the first term, the r, and then we need to get the n minus 1 for our exponent. So looking for the 50th term, we are using the common ratio raised to the 49th power. And using our calculator, we get this very large number here. This is written in what's called scientific notation. So that 24 would indicate for us to move this decimal point 24 places to the right to get an extremely very large number. Looking at another term in this geometric sequence, how about if we were looking for, say, the 10th term? If we were looking for the 10th term, well, then we have our n equals 10. N minus 1 would be 9. We have our first term is the same at 7, and our common ratio of 3. So at this point, hopefully you may better understand that we are doing substitution into the general explicit formula to find our 10th term, which wasn't quite as large, 137,781. It's a 5-minute video. Please watch it again. Take some notes. Try to make up your own problem. Bring it to me and I'll be happy to look at it. and we want to make sure you're understanding and improving your knowledge about sequences as we continue this adventure. And always remember that you can do the math. Thank you, and if you like the video, please give it a thumbs up. Comments are always welcome, constructive and positive, please. Always looking to make things better to help students learn.